The next item on the agenda is to isolate just the wetlands because that's the area that we want to quantify. And if we open up the attribute table, now that we have a vector representation of our raster data set, we open this up and we do have the values of land covers, but we don't know what they mean yet. We know that they mean different land cover, but how do we find out? Well, luckily, when we downloaded our data, we had all of these other files that went along with it, right? We've got an accuracy file and a couple of text documents. Now, if we look at looks like it says lookup. Aha, here we go. It tells us in a comma separated value table, 2 means high intensity development, 3 is medium intensity developed, 4 is low, etc., etc. We might find, oh, wetlands equals 15. Well, we could just go ahead and do our select by expression and just select all of the 15s. But I want to show you that if you want to bring in those names, the text version, right now we just have an integer, right? We have an integer field that is saying what things are, and it's kind of a code, an ID. I'd like to join that table here so that we can see the names of each land cover type in the GIS program. It'll make it a lot easier. So in order to join that table, we have to add that table to the map first. And you might go down here and say, aha, text, and you try to drag it in. Uh-oh, layer is not valid. So what we have to do is we're going to go over here to this kind of apostrophe looking thing. It says add delimited text layer. Well, all that means is it's the only way we can really add a table. All right, so we go to browse, and it's going to hopefully navigate us to our desktop tutorial 1 folder. And it's letting us see .txt, .csv, and of course these are just formats of kind of tabular data. We have a .txt, and it's a main land cover dataset lookup. That's what we decided was useful with the codes. And they're comma separated, so keep that in mind. We're going to look at that. So I say open, and it knows already that it's a CSV, comma separated values. Sometimes it might be separated by a tab or a semicolon or other things like that, and then we would choose something different, but we'll get to that in the future. So what else does it say? Number of header lines to discard. Well, sometimes with census data, there's lots of other headers, but we just have 2 headers. We have 1 header in 2 fields, so we have a value and type, and that's just one header. We don't want to get rid of that. That's useful. We're going to keep it. Because we say we can check this box and it says first record has field names. So these field names here are actually in the first, we'll look at it again here. This first kind of record are the field names in this file. So what we do is we keep that checked, that's fine. And you've got all these options. It says point coordinates. Well, it's not going to let us hit OK because there's no latitude and longitude. Sometimes a text file might literally just be a table, but it has a lat and a long. But we don't have any geometry to this. This is just an attribute table. So we hit no geometry, and it's saying OK. And what's nice about this kind of window is that it shows us here what it's going to look like. And if we had the wrong thing here, if we said custom delimiter, see it's not going to work. It's just bringing it all in line by line. We want it to separate them into different fields, and the comma separated value is the only correct way to do that. So no geometry, OK. Now lets us have our table in our layer panel. It doesn't have any geometry, so it doesn't show up, right? Because there's no geography to that. It's just information. It's just attribute information. So in order to join that table to this shapefile, we're going to right-click or control-click and go to Properties. And when Properties comes up, you'll see Joins. We have this option to kind of join the table. And let's go to Joins. I'm going to hit the plus sign. I'm going to add a table, join layer. So we're already in that Lincoln County thing here. We don't want to join a shapefile to it. We want to join the main land cover dataset lookup table. So join layer is going to be that table. Join field. Now what do you suppose that means? We need a way to describe, let me do that. Go out here for a second. What is the same between both tables? The code. The code is the same between both tables, the integer values. So the join field is actually going to be value. And dn, I don't know if you remember, I'll show you. In the attribute table, dn right here is the only field, but it's going to be the join field, right? So dn is the same as value in this table, value in dn. All right, sorry for the scatterbrainedness. I just want to show you that. So properties, add a join, join the table. The join field is value and dn. Those are the same. And we're going to cache it in virtual memory. And what that means is that when we say OK, and once it's joined, it's just stored in the memory. And what that means is that if I remove this shapefile and bring it back in, the join won't stay. We have to save it as a new file in order to keep the join. But if I open up the attribute table now of this vector file, I should be able to see, yep, main lane cover lookup underscore type, and it kind of has joined that table to our shapefile. And that just helps us so that, let's say we wanted to go and symbolize, right, style. We wanted to symbolize by category, right? We could say, instead of what is classify, here are all the land cover values, right? But instead of doing that, we could say, well, we want the name because that means more to us because we're humans. And there we go. It shows us what things mean now, and that's kind of cool. And now we can see that our vector file can be symbolized however we want, and we can see the names. But we're trying to isolate just the wetlands. So how are we going to do that? Well, I'm going to select by expression because I think that's the most meaningful thing to do. So go up to my attribute table, and it'll be the easiest if I say select all of the shapefile features where main land cover lookup type equals wetland. So in order to make that selection, I need to go back to my select features using an expression. And I say, okay, where this, right, equals all unique values, and I find wetlands, I say select, and I hope that works. I close. I can't really see it right now, but you'd see the selection is in yellow. So what do I do to make a new shapefile of just wetlands? I'm going to do a right click, and say save as, and then I'm going to call it Lincoln Wetlands. And the coordinate system stays the same. Save only selected features. We want that. I say OK. Let's see what happens. It should save. It as a new file. So now we shut off Lincoln land cover. There are our wetlands. Very cool. So let's open up that attribute table and see what it looks like. Well, we know they're all wetlands, so it's pretty redundant, isn't it? Now we don't really want just wetlands. We want wetlands by town. That's the measurement we want, right? So what if I bring in my township file now? And I can put the township file kind of underneath the wetland file so I can see them at the same time. The symbology is kind of hard to understand right now, so I think I'm going to go here under properties, and I think I'm going to make it a little transparent to kind of fade it away. There we go. How can I identify these wetlands by town? Now, it might be kind of confusing, but I think it'd be cool if there was almost a way we could intersect these two, so that we make a new file. Instead of just being all wetlands, it's each wetland where it intersects the town in its attribute table won't just say wetland. It'll say wetland and then Edgecombe or Newcastle or whatever town it's intersecting spatially. So let's try that. Let's look at this one attribute table first to see what is going to be brought over. Ooh, and there's tons of information. And we probably don't need all of this information. All we care about is the town name. That's what we want to intersect and create a new file with the wetlands. So I'm actually going to delete some columns here, and it's not letting me. I wonder why that is. It's because the edit mode hasn't been turned on. So I turn on the edit mode, delete the columns. I'm going to delete everything but town because that's the name I care about. So I say OK, and it's going to take it a couple minutes. Okay, there we go. So now we've just got a town file that records only the name of the town. And I'm gonna, one thing you always have to remember to do, you see that little pencil there, you have to remember to save the layer edits and then stop editing. So toggle editing, you shut it off by saying toggle, like that. I'm gonna take these two files now and intersect them. And these are both vector files, so we're going to look under the vector tool set. And this is a geoprocessing tool, which basically just means it's actually making the shapes of the features interact. And look at that, there's an intersect tool. Let's try it out. I'm going to intersect Lincoln County, Lincoln wetlands with the main township file. All right. I'm going to say the output shapefile, let's call this town wetlands. And let's give it a go, run this tool. All right, so now we have our wetland by town shapefile. Let's check it out. I'm going to open town wetlands, the attribute table. There we go, very cool. We can see that every wetland now has a town that labels it. All right, that's all I'm going to do for this video. Just to recap, in the first video, we isolated Lincoln County from all the counties. Then we used that shapefile to clip the land cover raster. We converted the land cover raster to vector. Then we isolated the wetlands, and then we intersected the wetlands with the towns to identify them by town.